Hello viewers, I am Dr. JEYAKUMAR, Associate Professor, Chemistry Section of Faculty of Engineering and Technology, ANNAMALAI University. Today in this lecture we are going to see regarding corrosion. Corrosion is a subject in engineering chemistry, that is especially in ANNAMALAI University, it is in the second unit, part of second unit. So here we will see detail about the corrosion. First we will go from what is corrosion. Corrosion, if you heard the word, you may know something about the corrosion, but I will start from definition and the mechanism of corrosion and what are the different types of corrosion and how the corrosion can be controlled by different methods. So these are the content of this topic. First I will say the definition of corrosion. What is corrosion? Corrosion is taking place in metal surface. All of we know it is taking place in the metal surface. When a metal exposed to the environment, either the environment is a gaseous one or the liquid environment, the metal surface will react with the environment and form the compound. So in definition I am mentioning here, any process in which the pure metal is converted to its compound by the action of environment is called corrosion. So by the action of environment, slowly the metal is converted to its compound. That process is called corrosion. We know the rusting of iron. So that is the best example. One of the examples or rusting of iron. Everybody knows when an iron piece is kept at an atmosphere for a long time, there will be a rust formed over the surface. So that is called rusting of iron. So what is rust? Nothing but oxide. Okay. Iron is converted to its oxide. So iron oxide is, we are calling it as rust. So that is happening everywhere we are seeing. Then another example, these two examples I am mentioning in this slide, people know, known example, no, rusting of iron. The other one is when we keep copper vessels in our home during the winter season, especially in winter season, you can see the green film over the surface of the metal. What it is? Because of winter season, there will be a humid moisture will be there in the atmosphere. So because of moisture and the presence of carbon dioxide, there is a formation of copper carbonate and copper hydroxide over the surface of the metal. So we can see the green film. So that is also a corrosion. So any metal which converts to any compound is called corrosion. Then this corrosion is classified. The corrosion is classified into two types. One is a dry corrosion or chemical corrosion, another one is wet or electrochemical corrosion. Corrosion is a chemical reaction, okay. Corrosion is a chemical reaction, it's a slow reaction, but all chemical reactions must have some mechanism. So based on the mechanism we are classifying this into two types, dry and wet or chemical or electrochemical corrosion. Okay, then we will see one by one here. Dry corrosion, we will go from the dry corrosion or chemical corrosion. From the name itself I think you can understand what is dry corrosion. So dry corrosion is one in which the metal reacts with the atmospheric gases in dry condition or in absence of moisture. Okay. In absence of moisture or in dry condition, metal slowly react with the environment. So definitely it must be a gas. Definitely it must be a gas. So only the metal surface and gas reactions are called dry corrosions. In dry corrosion, we are again the dry corrosion or chemical corrosion, we are again divided this into two types. One is oxidation corrosion, another one is other gases corrosion. So what is oxidation corrosion? The name itself we may understand what is oxidation corrosion. Only the metal which reacts with the oxygen in the atmosphere and form the oxides over the surface are called oxidation corrosion. So this corrosion takes place in dry atmosphere. So we are coming this in the dry category. Okay. So oxidation corrosion or dry corrosion, only the reaction between oxygen and metal surface. So in oxidation corrosion takes place almost in all metals. In the case of alkali metals like sodium, potassium, or alkaline earth metals like calcium, magnesium, even at room temperature it can react with oxygen. But when you increase the temperature or at elevated temperature, almost all the metals can react with oxygen react with oxygen except some noble metals. I am mentioning here silver, gold, platinum. Okay. So, what is the mechanism? Nothing, very simple mechanism. First the metal loses, that is oxidation takes place over the metal and it loses electron and making Mn2 plus or M2 plus, Mn plus, okay, Mn plus or M2 plus. Then this electron is accepted by the oxygen molecule in the atmosphere and forms oxygen ions O2 minus. Then both these two will combine, metal M2 plus and O2 minus, these two will combine together to form MO. So, simply I am writing here as metal plus oxygen is metal oxide. So, this is the only dry condition. So, this is a simple mechanism. So, in oxidation corrosion, we are is most important compared to other gases corrosion, because almost all corrosions are because of oxygen. So, how the oxygen corrosion can proceed? So, the oxidation corrosion or oxygen corrosion proceeds based on the oxide layer formed over the surface. Once the metal is exposed, the oxide layer will form. Okay. Then further corrosion of the metal depends on the nature of the oxide layer. So, there are 4 states of the oxide layer: stable, unstable, volatile, porous. So, if the oxide layer is stable, what will happen? So, I think you may understand, once the metal exposes with oxygen, oxide layer is formed over the surface. Then further corrosion depends on the nature of the oxide layer. So, if the oxide layer is stable, what will happen? If the first thing, if the oxide layer is stable, layer is stable, then what will happen is there is no further corrosion, see, there is no further corrosion. Okay. If then what will in no further corrosion cases, oxides of aluminum, tin, lead. So, in these cases, the corrosion, once the oxide layer is formed over the surface, there will be no chance for oxygen further penetrate in or the metal ions come out, because the stable layer is a highly protective one. Okay. So, in this case, if the oxide layer is stable, no further corrosion. Once the oxide layer is formed, then there will be no further corrosion. If it is unstable, what will happen? The second case, if see in the picture you can see metal is exposing and over which the oxide layer is formed, and the third one is if it is unstable, then it will decomposes to metal and oxygen immediately. So, there is no possibility of corrosion in unstable cases. So, what are those metals? Oxides of gold, oxides of platinum. So, those metals, when you heat very high temperature, a surface is converted to oxygen, but slowly it will be decomposed to metal and oxygen. So, no corrosion in the case of unstable cases. Then the third one is volatile. If the oxide layer is volatile, what will happen? For example, molybdenum oxide is a volatile in nature. Volatile, I think you understand, easily evaporate. Okay. The oxide layer can easily evaporate. Once the oxide layer forms, it will evaporate. After evaporation, again the fresh metal will appear to the atmosphere, the same atmosphere. Again molybdenum oxide will form, then again evaporation. So, this process will continue and the metal will be completely corroded in the case of oxide layer is volatile. And the fourth one is if it is porous, that is if it is porous. Porous means there is minute pores over the surface of the oxide layer. So, if there is pores are there, then what will happen? The oxygen can easily penetrate again and again, and metal ion can come out easily through the pores. So, there is a chance for the meeting of oxide O2 minus and M2 plus. So, there is further corrosion. So, in the case of porous, the metal will be completely corroded. For example, iron. Iron oxide layer is a porous one, so it can be completely corroded. Oh, then we are giving more important to the oxidation corrosion. Okay. Then we will see what is other based on this there is a rule called filling bed worth rule. in what is the rule? One man, that is Pilling Bedworth, he proposed a rule: if the metal oxide volume is greater than the metal volume, the formed oxide layer is protective and non-porous. That means, if the volume of the oxide layer is more than the in the whole surface, the covered portion is higher than the non-covered area, then automatically it is a protective. It is a protective. Compared to the protective surface area, if the protected area volume is more, then it is a protective one. It is non-porous, then it is safe. Okay. Example, aluminum oxide. Aluminum oxide. There I forgot to say, in the protective oxide layer, aluminum is a very good. Aluminum oxide is a very good protective oxide layer. Okay. In these cases, the volume of oxide layer is greater than the volume of the surface over which it is formed. Second one is, if the metal oxide volume is less than the metal volume, the oxide layer is a porous and hence it is non-protective. Okay. I think you may understand. If the volume is less, then automatically there is a chance for the reaction between oxygen and the metal surface. So, definitely corrosion will be there. So, this is the Pilling Bedworth rule. Here some alkali metal and alkaline metals in lithium, potassium, sodium, magnesium. So, those metals can oxide layer of these metals are non-protective. Okay, non-protective. Then we will move to the other gases corrosion. Other gases corrosion. So, we saw what happened in oxidation corrosion. Oxidation means only oxygen with metal surface. But in the case of other gases corrosion, other than oxygen, carbon dioxide, sulfur dioxide, hydrogen sulfide, then hydrogen chloride gases. So, in industries. So, we are not, why we are not giving much importance to other gases corrosion. Other gases are not possible everywhere, okay. Especially sulfur dioxide, you take sulfur dioxide, only possible in some industries or in chemistry laboratories, some industries or industrial areas. So, only these areas can expose with the other gases much. So, in the case of other gases corrosion also, what we are going to tell is, if the film formed over the surface or the corroded product is highly protective, then there is no further corrosion. Okay. In other gases corrosion also we are saying the same. What is silver? Well, I will give one example. Silver reacts with chlorine gas, then there is a formation of silver chloride over the surface. Silver chloride is highly protective. So, further penetration of silver ion is not possible. So, silver chloride is a protective one. Then second case, non-protective. The same chlorine gas is reacted with the tin metal, Sn, tin metal. It will form SnCl4, tin chloride. Tin chloride is volatile in nature. Okay. Tin chloride is volatile in nature. So, there is no possibility. Further corrosion is volatile, means we know there is a possibility of corrosions. So, these two things we are seeing here, other gases corrosion. Okay. Then we will see them what is wet corrosion. Up to this we are seeing what is a dry corrosion. In dry corrosion we saw oxidation corrosion and other gases. The next one is wet corrosion. Wet corrosion conditions itself is different. When a metal or two dissimilar metals or an alloy which are partially exposing with moisture, what will happen is, then electrochemical cell, a galvanic cell is set up over the metal, okay, and one part of the metal will be act as anode and the other part of the metal or the environment will act as the cathode. So, that is the points I am mentioning here. The metal is oxidized to metal ion and the ions leave the metal lattice and pass into the solution. Just you read this is okay. A galvanic cell is set up. Immediately a galvanic cell is set up. So, what will happen is, if it is partially exposing with moisture, then immediately a galvanic cell set up and a part of metal which is acting as anode can corrode. Okay. We will see the mechanism of wet corrosion. At anode what will happen? In all, because wet corrosion is in presence of moisture, okay, in presence of moisture. So, definitely at anode a metal dissolute, that is what will happen, oxidation reaction, metal gives metal Mn plus, in general I am writing Mn plus and electron, okay, oxidation reaction takes place at anode. So, oxidation, where the oxidation takes place, that place will be corrode. Then the electron move towards the cathode through the other part of the metal and reaches the cathodic part. I told the cathodic part is either either other part of the metal or the environment. So, it reaches the cathodic area. So, this is the mechanism based on this. This is the general mechanism I am writing here. So, there are two types of mechanism in the case of electrochemical corrosion, depends on the environment. If the environment is acidic, then what will be the nature of the corrosion, or if the environment is neutral, then what will be the nature of the corrosion. Okay. If we will see first the hydrogen evolution corrosion, that is, this is the case in which the environment is acidic. Okay. There are two different mechanisms, one is hydrogen evolution mechanism, another one is oxygen absorption mechanism. In the case of hydrogen evolution mechanism, what is the condition? If the metal is partially exposing with acidic medium, if it is partially exposing with acidic medium, what will happen? Okay. The part which is exposing, see in this diagram I am showing the part which is, see, this is the part, one minute please. Okay. Anyway, in the case of see, in the you see the diagram, in which a small area you can see, though the base is the metal over which the acidic solution is there. Okay. Base is the metal over which the acidic solution is there. So, one part of the metal is exposed with the acidic solution, then immediately that area will be act as the anode. So, if the anode, what is the reaction at anode? Fe gives Fe2 plus 2 electron minus, that is the oxidation reaction at anode. Okay. Then the electrons are liberated at anode, flew through the metal to the anodic electrolyte. Therein it combines with H plus ions. See, the environment is acidic environment. So, yes, acidic environment means there is plenty of H plus ions are there. Okay. H plus ions are there. So, these electrons are accepted by the H plus ions in the solution in the environment, and hydrogen gas is liberated. Okay. This we know how hydrogen gas is produced in a laboratory in small scales. In schoolings we are studied, no, when a metal is put it into the what we can say acid solution, mineral acid solutions like hydrochloric acid solution or sulfuric acid solution, dilute solution, then immediately hydrogen gas will be liberated. So, that is there, that is happening here also. Okay. One part is oxidation, another part the electron is accepted by the H plus ions in the environment and hydrogen gas is liberated. So, this is one mechanism. This mechanism is environment is acidic. Then the next mechanism is when the environment is neutral. Okay. This is called oxygen absorption mechanism. This is we are seeing everywhere. In most of the area the metal is exposed with a neutral medium, or we can say just water. Water is the metal is exposed with water. When the metal is exposed with water, what will happen? See, that is the best example is rusting of iron. Okay. Rusting of iron. I will show the diagram. See, here you are seeing a surface, no, a metal which is covered with an oxide layer. There is a break when the corrosion will starts. If the oxide protective layer is break any area and the metal is exposing, okay, If there is any break in the protective, suppose a metal is coated with paint or a metal is coated with a metallic coating and there is any break and that area is exposing with water, then immediately the corrosion starts in that area. We can see in our day to day life, you are seeing where the corrosion starts. Then what is the mechanism and what is the chemical reactions there? Immediately the area which is exposing with moisture will act as anode. Okay. Anode means the previous reaction, that is Fe gives Fe2 plus and 2 electron, because we are taking example as iron metal. So, if we take iron as an example, then the reaction is Fe gives Fe2 plus 2 electron. Then at cathode, what will happen at the cathode? Cathode is the neutral. Cathode is the neutral environment. Okay. So, the electron move towards the cathode through the metal and reaches the cathode. There, what is there in the cathodic area is the neutral area. So, we know plenty of dissolved oxygen is there in water. So, with the help of that dissolved oxygen, water, OH minus ions are formed. Then these OH minus ions are again combined with Fe2 plus and form ferrous hydroxide. Ferrous hydroxide. So, this ferrous hydroxide is deposited ferrous hydroxide. Then this ferrous hydroxide further react with oxygen and water. Okay. Further it will react with oxygen because it is continuously exposing with a neutral medium. So, it will react with the further oxygen and water and forms rust. So, what is the exact formula of rust is Fe2O3 and number of water molecule also. So, here I am putting 3 water molecule, depends on the environment, there is a number of molecules will change. So, Fe2O3 ferric oxide is a compound of rust. So, this is the important mechanism, is a common rust formation mechanism. So, we are saying as oxygen absorption mechanisms. So, in electrochemical corrosions, there are different types. These two are mechanisms. Then different types of corrosions are there. That is based on the environment. Okay, that is called types of wet corrosion. Types of wet corrosion. So, first one is galvanic corrosion. What is galvanic corrosion? I think we studied galvanic cell in electrochemistry. So, based on that we are giving the name galvanic corrosion. In galvanic corrosion, condition is when two dissimilar metals are partially exposed with moisture. What is two dissimilar metals? In many places there are two dissimilar combinations are there. A vessel is one metal made with one metal and screws are another metal, and equipment is one metal, screws are another metal. So, like this there are a combination of two dissimilar metals. So, if two dissimilar metals are partially exposing with moisture, then what will happen? The metal which is possess high oxidation potential value will be act as anode. Here see, in this example I am taking zinc and copper. Here I am taking zinc and copper as an example. Okay, zinc and copper. There are two metal combination, one is zinc, another one is copper. There are two metals are combined and both of them are partially exposing with moisture. Then immediately what will happen is, at anode the zinc dissolutes, that is zinc gives zinc 2 plus and 2 electron minus, oxidation reaction, that is all, liberation of electron. Then why is zinc acting as an anode? Reason is zinc possesses higher oxidation potential value than copper, because here we are combining copper to zinc. So, when we take copper zinc couples, then zinc must possess more oxidation potential value and the oxidation takes place at zinc and zinc will be act as anode. Then next one is cathode. Then naturally cathode will be the other metal or the environment I told. So, the electron moves through the other metal and reaches the environment. There it will combine with the neutral water and oxygen forms oxide ions. So, this is the mechanism. Then further we know, further steps we know, hydroxide combines with zinc 2 plus forms zinc hydroxide finally. So, that is the final product, corroded product. I am not mentioning here, I am mentioning only these two equations, that what happened at anode and what happened at cathode. Okay. So, in galvanic corrosion, how it takes place? When two dissimilar metal combinations partially exposing with moisture, this is one type. And in this type, I am giving some examples: steel pipe connected to copper plumbing, steel screws in brass marine hardware. Okay. Then galvanic, how it should be prevented? What are the methods? Better we should not select two dissimilar metals to design emissions or something. And if we select any two metals, if there is must for selection of two metals to design anything, then we should select a metal which is very close in electrochemical series. Electrochemical series means arrangement of electrode potential values in order. So, simply I can say we must select a metal which is close in oxidation potential values, very close oxidation potential values. If the difference are very high, then rate of corrosion is high. Okay. Or providing a larger area to anode metal and smaller area to cathode. This how can I can explain? If you give a larger area to anode and smaller area to cathode, then what will happen is the receiving end is very small. So, electron receiving end is very small. So, corrosion at the anodic side is very, so rate of corrosion is less. We can minimize the rate of corrosion, or we can provide proper insulation between the two metals. We can protect, we prevent the contact between the two metals. So, these are the way to avoid galvanic corrosion. Next type is differential aeration corrosion or concentration cell corrosion. Here the condition is very simple. We can see if the metal rod is partially exposing with moisture. I am sorry. If the metal rod is exposing with different oxygen concentration. For see the diagram, you see, if the metal is partially closed or protected or covered with any protective coating and other part of the metal is exposing to the atmosphere, then the part which is one part of the metal will be more aerated and the other part will be less aerated. Okay. So, in this diagram I am showing that zinc rod is dipping inside some solutions or in water, and some of the rod, some part of the rod is exposing to atmosphere where the oxygen concentration is very high, and the part which is dipping inside water, oxygen concentration is low. So, in this case what will happen, a concentration cell, we studied there in electrochemistry what is concentration cell. So, that concentration cell is set up within the metal because of oxygen concentration difference. Okay. One part of the metal is highly exposed with oxygen and another part is low oxygen content or less exposed. So, what will happen? The metal which is low aerated or poor oxygen exposure can act as anode. Okay. That can act as anode. So, the part inside the water, the nearby the line will act as anode and the corrosion starts in that area. Zinc dissolutes to give zinc 2 plus and 2 electron minus. So, if the oxygen concentration is different for the same metal, the metal which is less aerated or low oxygen concentration can act as anode and the other part will be the neutral area. Then the electron move towards the other part and reaches the environment, there it forms OH minus ions. The equations are same. When the environment is neutral, the equations are same, half O2 plus electron plus water gives OH minus ions. Then this OH minus ion will combine with zinc forms zinc hydroxide. So, this is called differential aeration corrosion or why we are saying differential aeration corrosion means air concentration is different. Okay. If you take a plate and any iron plate is covered with some soil or sand, one part is covered, another part is exposed. After 1 week, you can see the part which is covered with sand is corroded, because that is less aerated. Practically, we can say these things. Okay. The next type is pitting corrosion. Pitting corrosion is also over the metal surface, but here is a localized form of corrosion. What is localized? Because of corrosion is not spreaded in sideways. It is a localized one, and finally a pit is formed. A small pit is formed over the in the metal surface. So that is called pitting corrosion. Pitting corrosion is mostly in non-ferrous metals also, non-ferrous metals, except here I am giving the iron as an example, but in non-ferrous metal also this pitting corrosion is taking place. So pitting corrosion, the same thing, mechanism and other things are the same. When it starts, when the pitting corrosion, there is any deformation over the surface, there is any deformation over the surface, any cavity, any crack, small crack, anything is there over the surface, and the metal is partially exposing with moisture, then immediately that area will be act as anode. Okay. That area will be act as anode, and the corrosion starts in that area. So at anode, Fe gives the same reaction, Fe2 plus 2 electron, and cathode also the reaction is same. So everywhere in electrochemical corrosions, if the environment is neutral, the equations are same, but what is the difference? Conditions are different. Okay. Here the anode is corroded and make a pit. Okay. It not spread to sidewise. So pit is formed. So this type of corrosion is a pinhole or pit is formed. So this is called pitting corrosion. Okay. These are the main three types. A lot of types of corrosions are there. These are the main three types of corrosion. Annamalai University engineering syllabus, there are minimum corrosion controlling methods. So I am presenting only 2 types of corrosion controlling method, or only one type, that is cathodic protection method. So what is cathodic protection method? Cathodic protection method is, so we saw all the types. Okay, we saw all the types, we saw the mechanism. So everywhere the corrosion takes place in the anodic area. Okay, anodic area. So if you convert, you forcefully convert the metal to be protected as a cathode, then you can control the corrosion. Okay. Corrosion can be controlled by forcing the metal to behave like a cathode. You understand? Behave like a cathode. What we can do? We can do something to the metal, and we are slowly converted the metal to the cathode, and thereby we are protecting the metal from corrosion, is called corrosion controlling, cathodic protection method. There are 2 types of cathodic protection. One is sacrificial anodic protection method, another one is impressed current cathodic protection method. We will see both. Okay. Sacrificial anodic protection method. So in this method, see, I'm sorry. In this method, these both methods, sacrificial anodic protection method as well as the impressed current cathodic protection method, in both methods, both methods are applied in underground pipelines. Okay. If the underground pipelines are the galvanized pipelines or iron pipelines, usually iron pipelines, we are using iron pipelines to carry the water, oil, gases. Okay. So underground pipelines are usually made with, in olden days, it was only with metals. Nowadays it is replaced by the plastics, PVC pipes we are using, but in long back we are using only metal pipelines. So when we use metal pipelines, what will happen is, the metal pipelines are lying under the surface, soil surface. Okay. And the pipeline moves towards 2 kilometers long, When the pipelines are lying under the surface, then the pipelines are exposed with clay soil, exposed with sandy soil, and in some places the pipeline will come up for usage, it will come up. So, different areas of the pipes are exposed with different oxygen concentration. So, there is a possibility of, and one part of the, finally the metal, the pipeline will come up to the atmosphere. So, we know differential aeration corrosion is possible. Okay, because one part of the metal is highly exposed with oxygen and the other part is lying under the earth. So, low oxygen exposure. Likewise, different soils are having different oxygen. So, to avoid this, we are using the sacrificial anodic protection method and impressed current cathodic protection method. In the first method, see, in the first method, the underground pipelines are connected with a anodic metal, like suppose the underground pipeline is iron, an iron, we are using a sacrificial anodic metal like zinc, magnesium. So, these metals are made like a block, and these blocks are connected with a pipeline 5-meter gap or the 10 meters gap connected with a pipeline. Okay. So, if you connect a anodic metal compared with an iron, anodic metal means the metal which possesses more oxidation potential value. So, if we connect a metal which is possesses more oxidation potential value with the main pipeline, then what will happen? There is a possibility of a galvanic cell or galvanic corrosion. Okay. Two dissimilar metal cases. If two dissimilar metals are partially exposing, we know what will happen. The metal which possesses more oxidation potential will corrode. So, here see in the first diagram, the block is a sacrificial anode, or we can say anodic metal. So, this anodic metal will start corrode and it will protect the pipeline slowly. Okay. So, if you connect a sacrificial anodic metal with the main pipeline, that is the metal which is to be protected, we can say it as a base metal, the metal which is to be protected, to which we are connecting the blocks, sacrificial anodic blocks, then slowly the corrosion is only in the sacrificial anodic block, and the corrosion is totally, the corrosion in the pipeline is protected. So, finally what will happen? The sacrificial block will be corroded. It will sacrifice itself and protect the base metal. That is why we are saying it is a sacrificial anodic protection method, okay, because it sacrifices. This is one method. Another method is impressed current cathodic protection method. Here we are converting, same principle, we are converting the base metal or the metal part to be protected is converted to cathode anyway. There we are converting the part, the first case we are converting the metal to cathode by connecting an anodic metal. Here we are passing a minor current by using alternate current, by using a batteries 3 volt, 2 volt, current is passed over the base metal which is to be protected and make the base metal as negative side, okay, cathodic side, and the anodic side will be the some inert blocks like graphite block, lead block, graphite blocks are connected there. Okay. While passing a minute current through the base metal, what will happen is the base metal which is to be protected is acting as a cathode, and the other part means the what is the block, that is the graphite block or the lead block which is connected with the pipeline will be act as the anode. So, artificially we are supplying a minor current to the base metal, we are converting the base metal to the cathode. So, these are the ways to protect, you just read, okay. these are the ways to protect the base metal from corrosion. So, these are the best method of protecting the underground pipeline from corrosion. Okay. So, viewers, thank you very much for listening my lecture regarding corrosion. Here we saw what is corrosion and what are the various mechanisms involved in corrosions, and what are the ways to protect metals from corrosion. Okay, viewers, thank you very much. Up to this we saw what is corrosion and what are the various types of corrosion and mechanism involved in corrosion, and how the corrosion may be controlled by various processes. Thank you very much for listening. Thank you.